Next speaker is Jay Detjens, who's a GIS analyst for the Cape Cod Commission, and he has been working on wastewater. In fact, his system has been called SimCity for Wastewater Geeks. So his talk is about comparing and communicating wastewater treatment scenarios with Geodesign. So you're on, Jay.
Thank you. Oh, wow, wastewater for geeks. My name is Jay Detjens. I work for the Cape Cod Commission. The Cape Cod Commission is a government agency with Barnstable County in Massachusetts. We are the planning agency for all of Cape Cod. Cape Cod is really kind of one big hook, all one county, so we have to combine all the regional data for that area. Not to get into the history too much, but Cape Cod, pretty little Cape Cod, has a really bad wastewater problem. It was developed very quickly with very poor zoning, and 80% of Cape Cod is still on either cesspool or septic. There's very little sewering going on. So we've been tasked with updating Section 208 of the Clean Water Act for the EPA and for the Massachusetts DEP. And so we had to figure out a way to start creating some scenarios for wastewater planning. And so what we did is we tried to figure out how we could put all the data together, be able to get something to the public that we could communicate to them, and create an interface that we can share information. So this is my Ian McHarg slide of moving data, mashing it together into Watershed MVP. We use zoning data. We did a build out for every parcel on Cape Cod. We got water use district data for every parcel on Cape Cod. And we merged all that data together into what we call Watershed MVP, which is an online tool that anyone can log on to, watershedmvp.org. And you can literally zoom into any area you want. You can go into a town, you could go into a neighborhood, you can go into a watershed, and you can start to see data associated with that town. So you can start looking at land use, who's already sewered, and then you can start drawing polygons. Here's a scenario built by someone depicting where they would want a sewer. And then the associated nitrogen load is calculated from that, and then you start getting costs associated with that. This tool we actually debuted or showed at the last Geodesign conference. So what ended up happening was this was really just one scenario at a time. And our planners and our engineers were building a scenario after scenario after scenario, and it was getting very difficult to compare scenarios, and the list of all the scenarios was getting very large. So we decided, how are we going to be able to compare different scenarios to each other? So then we took Watershed MVP even further and created Dashboard MVP. So for all these slides, I'm going to use this Lewis Bay watershed, which is where downtown Hyannis is. And now we could take up to 3 scenarios and begin to compare them against each other and start figuring out what the individual load is for each one of these. This is kind of a boring slide just because everyone tried to do sewer facility inside the watershed, but then you can start seeing how we're comparing different scenarios to each other. But we slowly got handcuffed in this format as well because we started only looking at gray solutions. So sewering, cluster systems, updating septic systems, or doing IA systems. We didn't get into anything that really kind of looks at more alternative ways of doing things because we had tried and true numbers for gray infrastructure. We didn't have tried and true numbers for green infrastructure. So we started to develop matrices and gathering research to start thinking about green solutions. And by green solutions, I'm envisioning things that Kong Juan this morning was talking about, those changing constructed wetlands and redoing areas to start ameliorating stormwater impacts and start thinking about how we could clean water up just in a natural process. But there was different costs associated with that. It's very hard to measure it. There's not a lot of pieces out there to be able to look after. And then the other part of the piece of the problem was well, sure, it costs a certain amount, but that doesn't tell us the whole picture of what that solution is going to do. We want to start looking at what kind of job creation is going to happen there, what kind of change in open space is going to happen. So our new geodesign challenge is to start creating all three of these things to work together. So we want to start looking at green solutions, start being able to describe them in a way that's simplified. I mean, this is all very complex data. We're trying to communicate it to people that don't know too much about wastewater. I don't know too much about wastewater myself. We still have that Lewis Bay map area, so we can still select different areas that we want to apply different technologies to. But now we start thinking at the whole picture. So before, we would just be looking at maybe 2 financial pieces of the puzzle, but now we're looking at a couple more financial pieces of the puzzle, and then we have even more social economic indicators that we want to look at, and then we also have environmental indicators that we want to look at. Sorry for the fuzziness of this slide, but this is that pie now. So we're trying to use geodesign to be able to communicate large amounts of data, especially on a GIS basis, but also on an indicator basis, to give people a score for a scenario, and they can start comparing scenarios to each other, not just on how much is it going to cost or how much is it going to clean up, but also these other factors: system resilience, total employment. How is the distribution of the rate of that system going to be apportioned across that group of people? How is that going to change property values? What is the greenhouse gas effect of it? And then here's the other cost too. How much is it going to cost the town, but also how much is it going to cost each individual user? So before, we were looking at maybe marine quality and then maybe capital costs. Now we're trying to get a big picture of what's going on. So through partnering with AECOM, we're trying to create another way of just taking 3 scenarios again, and you can very quickly start looking at how those scenarios compare against each other and the different technology that's being used, and start to making a more informed decision about how you want to dive in and read more about a scenario. Because there's no solution on Cape Cod, the sky's the limit for us. So putting Watershed MVP online was a way to get all users to contribute to the scenario building. But as we got to the point of everyone was just making gray solutions, we needed to have something that would take it a step further. So this isn't necessarily online. Lessons learned. We ran into some problems doing everything online. Not everyone's an engineer. And if we made too complicated a tool online, we lost a lot of the public that we wanted using the tool. So now we've kind of come full circle back around, where we're using this back on a desktop model so that the engineers can really dig in on this kind of part. And then when the report comes out, the update plan comes out, we can start comparing scenarios and people can start making better decisions. So that's all I have. I'd like to thank AppGeo for sure, because they helped get MVP, Watershed MVP online for us, and they've been a partner the whole time, and they do great work for people looking for apps. And we're partnering with AECOM now, especially the San Francisco office, to create this triple bottom line model, which is those daisy little bullseyes that we have for analyzing scenarios. Thank you.